Hello and welcome back to Learn Synthesis with VCV Rack. I'm your host, Dr. Lawrence W. Moore, and in this episode we're going to be looking at two of the modules that are in the KautenjaDSP module library for VCV Rack. The KautenjaDSP module library is one of the free module libraries. All the modules in that library are free. They model vintage video game sounds, and today's modules will be Palette Town, which models the Game Boy sound system, and Infinite Stairs, which models a Ricoh 2A03 chipset. If you don't know what chipset that is, I think when you hear some of the sounds produced by this module, it'll be like, oh, you know, it'll stir up some memories if your memories go back that far. In any case, these are powerful tools for making some vintage video game sounds and music that utilizes that type of sound. And since VCV Rack is free download and this module library is a free download, if you're inspired by this, watch some of the other episodes in this series, get up to speed with VCV Rack, and go to town. This will be cool stuff, all right? So let's get going. Okay, so the patch that I set up here today and we'll be working with has a number of things, but these are the two modules that we'll be focusing on. This is Infinite Stairs, and this is Palette Town. This models the Ricoh 2A03 chip, and this models Game Boy sound system. Now, these other modules here are not part of this library, but they are part of a free library. These piano rolls are modules from the RCM module collection. And since they don't have an internal clock, in order to play these sequences, I'm using this clock generator here from the Sicovel module library, which is also free. Earlier in Series 2, we went through the Shebang series of modules, and one of their modules is a clock also. So I already had one, but I wanted to try out this one, and also I wanted to add Sicovel to my library for the future. Yeah, there's a lot of episodes coming up on different libraries that I have downloaded. A lot of cool stuff coming. But anyway, let's get back to this. So if you've seen episode 5, the previous episode, we worked with a similar design of module, two of them in fact, but they had 3 voices. These are 4-voice modules. The 4th voice here on the Infinite Stairs is a noise generator. The 3rd voice here is a triangle wave generator. Right now I have a gate going to its channel over here. Basically, channels 1, 2, 3, 4 are going into 1, 2, 3, 4 on this mixer. I'm using the gate from this one piano roll down here, because eventually I will be, we'll be hearing this channel and the triangle wave, and I have it over its CV amplitude control here on the mixer, because there isn't an amplitude control here on the module for voice 3. I would assume it's because maybe in this chipset, the Ricoh 2A03, there was no amplitude control for the triangle wave, I assume. But anyway, just to explain that, how things are hooked up here. So we're going to be hearing channel 1 in a moment, and that's hooked up here to channel 1 on the mixer, which I do have up. And so we could hear the sound of, this would be a square wave or a form of pulse wave. There is pulse wave modulation here. And let me just start it up. Just need to start the clock here. Okay, I wanted to turn that down because it was a little bit loud on my end. So let's try a little pulse width modulation here. It's more like a multiple location switch. It didn't do a gradual change there. I've counted about 4. Now, you see I turned down channel 1 on the mixer here? We still hear sound. What is that coming from? That's coming from this one right here on channel 2. Because unlike we looked at some modules last time, and the different channels on it, had these arrows indicating that this would also drive this, and this will drive this, and so forth. If I didn't have an output cable here from channel 2, we wouldn't hear it. We would only hear the output from channel 1 if that's the only one I had a cable on. Although the information goes over to these channels, but as long as their cable's not hooked up, you don't hear them if they're to the right of the channel before. But since I had its cable hooked up, we were hearing this second square wave, basically, a second pulse wave that has the same features as channel 1. So you could chorus them and use that to some effect. Like, for example, here, I'll turn them both back up a little bit again. Come on, mouse. If you're careful and don't tune them apart by so much, you could get some good chorusing that is still kind of in tune. And then you could use numbers here, for example. Let me initialize this one again. I could take whatever its pitch is and say minus 1.2. That would be minus 1.2 hertz. And do the opposite here. Or did I do the opposite? Here, let me try that again. I think I typed a minus again. Plus 1.2. So now they're a total of 2.4 hertz apart. And you hear this chorusing effect. But since they're the same amount of hertz above and below a central pitch, you kind of perceive that central pitch. So that's a way to use those multiple square waves. And actually, let's try something here. Ah, come on, mouse. Let me turn that down. It's starting to drive me batty. But as you saw there, I was altering the pulse width here, and I could hear the effect. With this one, I did not. It looks like when... Possibly when both are being used, this one will override this one. But as we're about to see, another way of utilizing these, and we're going to initialize them. You would think it, since we have independent outs on each of these here, it would allow me to use pulse width on this channel. But I was not hearing a modulation there. Also, there is frequency modulation here. One way of using that is I'll take the, I don't have it hooked up, it looks like. Or do I? The triangle wave here, it's another use for it. Since it doesn't have, oh yeah, I do have it hooked up there. Since it doesn't have an amplitude control on it, it makes it a pretty good like frequency modulator here. So let's hear the frequency modulation on voice 2 here. I have its output going right into the mod input here, but you need to adjust this modulation up. Now let's hear that with the other oscillator. I'll initialize the pitches here so we don't have chorusing, but we will still have the modulation here. Sounds pretty cool. Sorry that the melody I have over here is a little monotonous, but I didn't want to take the time to compose a song, you know. Now I have these two hooked up, where basically the clock and reset are coming from like a through port, an out port from the top modules, so they're daisy chained together. And so this could be used now to control the second voice independently. You don't need to combine these together. And actually, I'm going to unhook the triangle wave from there, because we're going to hear it on its own. I still have this gate from the third sequence piano roll covering it so that we don't hear it right now, because otherwise we would, because there's no amplitude control here like we have for these. You see how I have the gate hooked up directly? And I'm going to hook up the gate here for voice 2, if it lets me. Thank you. And let's see here. This is out gate. There we go. And then it's pitch. CV pitch. Okay, so right now, since this is running, has a different sequence. Since it is running, usually I would see these light up, I think, when notes are coming in, but the gates are lit up. So yeah, we should hear them now. Two different melodies. that didn't sound as bad as it did this time when I was setting it up. I don't know what happened. But yeah, these piano rolls are pretty cool. If you drag from right to left, you can do multiple durations. I am going to do, so you can make a longer note and so forth. I am going to do an episode on these. The problem is, this episode's about the KautenjaDSP modules, but I will do an episode on RC and probably right at the end of this series because I have a few more episodes to do on this series of modules. In any case, so yeah, they could be used as separate independent voices, and then now we're going to hear our triangle wave on this third voice. Now these are, it looks like the sequences, yeah, they're on here. They're just bad note selections. I hit reset there, so now this one's running with the others. Okay, its gate's hooked up, and now I'm going to hook up the pitch here so we can hear the triangle wave here. And what I'll do is mute these. And put this one up. Now here we have gate, pitch control here. I turned you down. It also has modulation input that you can modulate with like a control oscillator. Now this would be best if I had an envelope or a slew so we wouldn't hear those snaps as much coming through. But as you see, the triangle wave doesn't have as much tonal control. You could hook another waveform up to it sync-wise, though. Get some pretty cool sounds there. There we go. So anyway, that's that. So you've heard all the tones here, except for, let me turn this down, turn this up, the noise generator. Okay, it's already up. All right, so here's a noise generator. It has area where you could kind of guide the pitch region that it is kind of emphasizing. So you do get a variety of noises out of this. And this is like a low frequency filter that we'll hear it when we do it. So to do it, what I decided to do was to set up just a button, and this button triggers the envelope here, and we get noise. Otherwise, the noise is just going to keep going on. It has amplitude control here, but pitch information from these sequencers over here really wouldn't do it much of any justice, because this knob up here that controls kind of like the frequency region, you'd have to go into different octaves to really hear differences. You hear that? So, and it really doesn't have much to do with the pitch that gets there. It's all voltage, at this point, voltage numbers. And the range up here, interestingly enough, is 0 to 15. Yeah, that sounds very familiar. So you could literally right click on it and put different voltage numbers on. Let's try the middle, something like 7.5. As you see, it's in a 12 o'clock position now. There you go. Of course, you could have a sequencer hitting this. Now, because its range is 0 to 15, like here, I have a knob that is 0 to 10 from the RCM modules. And I just brought this out just to demonstrate that if you wanted to change the noise frequency area with a sequencer or something, just pretend this is a knob of a step sequencer. This has a range of 0 to 15. This has a range of 0 to 10. And some knobs may have a range of -5 up to +5. I don't know. Let me know in the comment section if there's a knob range that has 0 to 15 like this does. Well, here's your knob right here, but like if you were using a sequencer, one with knobs, not piano rolls, it would be kind of hard to get the full range of this, but you could get an area. Like if I put this on 5, I can now use this knob to basically explore the upper 2/3. Now let me see here. I put this on 5, but if I turn this up even more, mathematically speaking, we should be at the top of the range, but I sort of, yeah, I knew we weren't. Maybe this is a -5 up to +5 module. Let me see here, 10. No, yeah, it goes up to 10, so this is a range of 0 to 10. So in other words, you will probably need to use this knob in conjunction with other knobs to kind of like get the ranges that you want. Incidentally, all these modules here, both of these are polyphonic, so you do get polyphony from them. You could get multiple notes at the same time. For the noise, you know, that would be interesting to see. Let me try that real quick here. Let's take a MIDI to CV. And if now I'll need to use pretty much the full length of my keyboard here. Get much difference because before I didn't hear a big difference between them. So now we're going to control that with normal pitch. We aren't going to get like filtered noise at the frequency of the pitch being played, I don't believe. Now let me do this. I'm going to turn you down first because otherwise we'll hear the noise the whole time I'm moving this cable. So we'll just do it rough and dirty. Oh, wait a minute. No. Keep you on here. Move you. So now the gate's coming from our MIDI in. And I need to select my keyboard. Got the volume down. All right, I'm doing the lowest key on this 49 key keyboard. Now I'm doing the highest. There, I did like kind of like a full octave scale, and it's sustaining the noise, but as you hear, there's no shift in pitch region till I get there, and I'm like more than halfway down the keyboard. So yeah, your region of pitches, it basically to change this noise, it's a wider range than, you know, if you have an 88 key keyboard, I don't know, but might go a little better. But let me try the mod wheel, and then I'll do the pitch wheel next. Here's the mod wheel. I'm not hearing any shift there. Oh, wait a minute. A little bit of shift with the mod wheel. Sorry, I was using the pitch wheel instead. Now, pitch wheel has more resolution in MIDI, but it's probably still converted to CV in VCV Rack. So anyway, depending on how you want to use these, that's something to keep in mind. Using this module, the noise range is going to be the range of values in that sorry about that, are pretty wide. So let me disconnect these. In fact, I'll just delete you. And now we're going to look at the Game Boy modeling from Palette Town. And here, its tones. Well, since I didn't select the best sounding stuff over there, how about I use this now? Oh boy. Well, no, I guess we could go with it. Here. Let's do volt out. Voice 1. Now we have 2 square waves again. And because of the pulse width here, we should say pulse waves. And then the third one is a wavetable. And here's your different waves that you can play from. And then I'll show you something else that's pretty cool about it. So let's hear our first 2 voices first of all, just so you hear their sound and their range of tones. Okay, yeah, I'm going to the gate. Gate's going on amplitude right here. All right, and then we'll take audio out from here. Pop you in there. Let's put your level up and then ease this up. Of course, we have about 4 different settings there, similar to the other one. And we have modulation. We could hook up cable up here. Yeah, I'm hearing a change. Not as drastic as the other module. So the modulation on this doesn't seem to be as strong. No, it's strong. Let me initialize this and hook up its volts per octave to the same output here. That's pretty cool. Oh, that's the wrong mod. Here we are. And you have amplitude here, so you can turn this modulating oscillator up more. Okay, so pretty cool. Lots of stuff can be done with these if you explore how the modules interact with themselves. Of course, this can be on a second voice, but I think we heard before this doesn't sound so high. So let's hook up here the wavetable oscillator, and we'll hear that on its own. in just a moment. I'm hooking its amplitude up to did I? Yeah, my color coding is green for gates. Although, yeah, there we go. Oh, good. Alrighty, now let me pop this on here. And we're going to turn you off and put channel 3 up. So right now, we're on this channel. This is all we're hearing. It has a wave knob. Obviously, there's a CD input, so you can change them. But there's really only 5 positions. 1, 2, 3, 4, 5. Actually, it's numbered opposite. 1, 2, 3, 4, 5. So if we set the wave to 1, we get this sine-like wave. Let me move this over so we can see it better. The cables are kind of... Oh, it looks like they're always going to be... Well, there's cable tension. Maybe I can get them to sag a bit more. I have to zoom in to see which one that is. Sorry for the second mouse cursor. There, they're sagging. Yeah, that's better. Now they're covering up this one. But anyway, so you see this is sine-ish. The little fluctuations here are really to model, you know, the bit resolution that these chipsets had. So what I'm going to do is you can actually draw in it a little bit. You can make it a square wave, square wave-ish. And if you don't like what you made, you can right-click on it and initialize again. So let's hear the other waves. Let's go to 2. Go to 3. 4. Oh, hold on. And there is a... Looks like we're already at 5. 4. Huh, hold on here. Let me try. 4 and 5 are sounding the same. Oh, I'm changing the wrong knob. 5. There we go. Yep, sawtoothy. So now, I'm going to go nuts here and just bring you up. Bring you up. Well, hold on. Before I bring you up. Oh, that's right. I have the master down, so we're good. All right. And let's hear these in combination with one another just for the heck of it. Now, the notes are probably not going to be the best notes. Let's disconnect you and send each of these different pitches from the different sequences. All right, now we can turn you back up. That's why. Okay, and yeah, this holds out for one pulse of the clock once you stop it. So anyway, there we go. I mean, if I was composing some music, this would sound better, but I was just trying to make a demo and demo the sounds here. And we have one more to do. So let's hook up our noise here. Once again, I'm just going to trigger this with a button. If you've been finding this useful or in any way entertaining, please hit that like button. I forget to say that until the very end, and a lot of people may have stopped watching by then. Now, here's our noise. We have droopy cables. That's not the gate output. That's the gate input. Hold on here. What's going on here? Oh, it was coming from up there. All right. So we want to take the amplitude here and hook that up to our gate output here. And take this button, trigger our gate here. So a drum sequencer can definitely execute these well, and that would probably be one of the best uses for the noise, is to make different drum sounds or percussive sounds. It may not sound like drums, but percussive sounds. So here we go. Now let me check the range of this here. Hold on, I don't want to zoom in with the operating system that much. But let's try different ranges here. Let me try 15. Yeah, it looks like it's like the other module where it goes 0 to 15. And our 10 value is right about there. Oh, wait a minute. Maybe this one goes 0 to 10. Yes, it sounds that way. It's not like the other one. All right, that's pretty cool. Let's try 5. This one, let's try 0. Okay. I thought 5 would be in the middle. You hear that the envelope is not really affecting that. That attack is from the noise generator. It has some sort of tones in its attack. Interesting. So anyway, folks, there we go. There we have it. What I'll be doing next time is I'm hoping, I've been trying to get this to accept a ROM dump that I downloaded. I have to probably just spend a little more time with it. But this is a Game Boy emulator that actually plays Game Boy games, and then you can use the sound outputs, you know, to basically integrate that with your music. So that's what I aim to work on next time. And then for the rest of the series, there's a few more modules in this library to cover. I'd like to have 12 episodes in the series. It fits well on the webpage and all that. So this will probably be episode 7. We have a pretty complex FM synthesizer here for episode 8, and then maybe 9, 10. This is just an ADSR, 2-channel ADSR, I believe. No, here's the ADSR. But basically, yeah, I want to basically, since there's a lot of cool modules in here, I'm going to basically do a couple more KautenjaDSP modules, and then I think I'll close things off with RCM. There's only a few modules there, but this piano roll module is pretty cool. It is monophonic. You can't have multiple pitches at the same time in it, but it is pretty cool. So anyway, thank you for joining me. If you've found this valuable at all for your knowledge or entertainment, please hit that like button, subscribe to the channel, share the video, whatever you can do to help this channel out. Thank you for those who have been joining. Subscriber count goes up every day. I appreciate that very much. So until next time, so long, and thanks for all the fish.